Okay, welcome to a deep dive.
Glad to be here.
So today we're digging into something pretty fascinating. We've got these sources looking at farm herbs, veggies,
Hmm.
and how we preserve them. But the surprising part, how much advanced math comes into play.
Right. Calculus, specifically integration.
Yeah,
Yeah.
integration and like trying basil, it seems worlds apart.
It does at first glance.
So our mission today is basically to figure out what can calculus tell us about nutrient loss when you're drying food from the garden.
Let's get into it because, drying isn't just about water leaving. No, it's a really complex process. The actual plant tissue changes.
Hmm.
And the key thing is the root nutrients are lost. It's not constant.
Ah, okay. So it's not like losing, say, 5% an hour steadily.
Exactly not. It really fluctuates. Depends on temperature, how much moisture is still left.
Right.
Even the specific compound. Think vitamin C in parsley, or maybe those antioxidants in basil you mentioned. They degrade differently.
Okay, that makes sense. The rate's faster maybe when it's really wet, then slows down.
Could be. Or other factors kick in. So the big question becomes, how do you possibly calculate the total loss over the entire time if the speed of loss keeps changing moment to moment?
Right. That's the puzzle.
And, well, this is exactly where the sources show integration is incredibly useful.
How so?
If you can model that instantaneous rate of loss, how fast nutrients are disappearing right now,
Okay.
based on factors like temperature or humidity, which these papers discuss,
Yeah.
then you essentially have a function, a mathematical description of that rate of change over time.
Gotcha. So you model the speed of nutrient loss as a function?
Precisely. Maybe it's like an exponential decay slowing down as things get drier. One paper suggested that for tomatoes.
Interesting.
Or, maybe it's more complex. Another study on leafy greens brought in airflow, temperature variations.
So lots of variables.
Yeah. But the beauty of integration is it's the tool for adding up all those tiny instantaneous changes, summing them up over the whole drying period.
Ah, okay. So you're sort of accumulating all those little bits of loss second by second.
That's the fundamental idea in these sources, yeah.
And the final number, that's your total nutrient loss.
Exactly. You set up the integral with that rate of loss function you figured out.
Yeah.
You integrate from time zero, when you start, to the final drying time, the result. It gives you the total quantity of nutrient lost.
Wow. So you go from just saying, yeah, some nutrients are lost to knowing exactly how much.
Precisely. Per gram, per pound, whatever unit you're using, under those specific conditions.
That seems really valuable. I think one source mentioned comparing sun drying versus oven drying for cherries.
I saw that one.
And they use this integration method to show a measurable difference in anthocyanin levels.
Yes, they could quantify the difference. Another paper used it to optimize drying temps for herbs,
Optimize how?
finding
Yeah.
that sweet spot, where water loss was quick, but the integrated total loss of those important volatile oils was kept to a minimum.
So it's not just measuring loss, it's using that measurement to make better decisions.
That's the real world power of it. You quantify the total loss, you get objective data,
Right.
you can compare method A and method B with hard numbers on nutrient retention. Takes the guesswork out.
It allows for like data-driven preservation.
Exactly. Improving quality, maintaining nutritional value based on calculus.
Calculus helping make your dried herbs healthier. It's kind of amazing when you think about it.
It really is.
It shows how these, abstract math concepts have these really practical tools hidden inside them.
Understanding the dynamics, those changing rates, and being able to measure the total impact, that's where integration shines.
So wrapping this up, what's the big takeaway here?
Well, I think it shows that even math that feels abstract, like integration, can directly help us understand and even improve really everyday things like keeping food good.
Yeah, we've seen how it lets you calculate the total nutrient loss by adding up the changing rate of loss while drying herbs and vegetables, which lets you actually compare methods, find better ways. And I guess this makes you wonder, where else might the math, or our learning connect with the world in ways you haven't thought of? Something practical, maybe surprising?
That's a great question.
Something for you to think about. Thanks for joining this deep dive.